Now we learn about heating system integrations, and let's look into this unit one by one. Let's integrate them one by one and use multiple inputs so we collect a beta data from each unit. Because the screen is too small, and if I will use a lot of wiring, you might not understand anything, I decide to take these units one by one and to show you how they integrated. Now I'm going to show you how the pressurization unit it is integrated. As you will see, only for the pressurization unit I'm using multiple inputs, and they're very helpful because they help me to collect comprehensive data about this pressurization unit. And if I were remotely monitor the heating system, I would be able to collect more data about the system, like I can even see if the pump is broken, or if I have a high pressure in the system, or maybe the main water supply it is interrupted and I don't have water into the water tank, and so on. So when I finish all this presentation, I'm going to do another video and I'll put all these units again together, comprehensively integrated. Then it will be very hard to understand because the picture will be very compressed. So let's go and see about pressurization unit integration. Obviously, when you'll start the HMI and the programmable logic control, you'll have the welcome screen, and then the human machine interface will display as usual the mirror of your installation. Onto the HMI you'll have multiple pages you can navigate to, and if you have a good programmable logic control, you can go in so much detail that you'll know exactly what's wrong with any system. After the welcome screen, the HMI will show you the item that you want to control, if the graphic is done well by the programmer. And this is a good thing to think about, to ask the programmer to do for you a good graphic design, so it will be easy for you to identify faults. Now, you know, some people like to enable the pressurization unit, fans, boilers, all through contactors that receive their inputs from the programmable logic control. Sometimes they directly wire in a power supply and they only control with inputs and outputs, either analog or digital. But this time, this pressurization unit, it is controlled by the PLC. So first, what I have to do, I have to turn on the isolated switch to allow the electricity from the contactor to get through straight into this pressurization unit, and then I'm going to use them to pressurize the system. So using the human machine interface, the HMI, I'm instructing the PLC to send an input to this contactor and to enable the pressurization unit. In the same time, the pressurization unit receive a lot of inputs from the PLC, which is waiting for these inputs to come back, and this is the way that the PLC will check the pressurization unit health status, and the health status will be displayed onto the HMI. If the pressurization unit is healthy, the color will change on the HMI and the system will be ready, and this is good news because it's fully functional, and we have no alarms. All the inputs are coming back into the PLC, and the HMI display tells you that everything is standby, ready to run. So this is good news. This time we've been lucky, but sometimes things are not as good as we think they are. And look now, the pump number 1 is faulty, and the HMI display the pump that is faulty. You have a red dot, and also on the right hand side of the HMI on the top tells you that the pump number 1 it is faulty. But this pressurization unit have 2 pumps, so this will run now in a limping mode. So you will still pressurize the system, but in the same time you will be warned that you will only run on with only one pump, and if that one crash, the situation will become a little bit odd. Because the business might be pretty important, we are not allowed to run on only one pump, because the pressurization can hold the entire heating system, and we take fast action, and we will repair the pressurization unit, and we reset the fault. As you'll see on the HMI, the fault disappeared, and the system is again ready to go. So everything runs well for a while until we have a kind of a warning that the pressure is too low. That's not an alarm. Sometimes the system losing pressure because the air eliminator eliminates the gases from the installation. Then obviously the pressurization unit will try to compensate that loss. Now the pressurization unit will wake up, and it will enable the pump try to compensate the pressure loss. As I said before, sometimes the installation get inside methane, or sometimes they can get air inside, and the air eliminator eliminate the air, or you have an unbalanced pressure vessel. There could be many things. Anyway, the pressurization fights to keep the pressure constant. You have to remember one thing instead. You will set up the pressurization unit for a maximum quantity of water to push into the system. Otherwise, if you have a broken pipe, you will flood the store, and that will be pretty unable for you and for the customer. So just make sure that you have a reasonable quantity of water, and do not try to put too much. Once the pressure will reach the value that is set up on the pressurization unit pump will stop. Until here, everything it is okay. Words are words, walk to walk, or talk to talk. So let's be a little bit curious, and let's go inside the pressurization unit. Let's see how the pressurization unit works. What is inside beyond this inside that box, and how it is integrated onto the PLC, and how the PLC understands the pressurization unit, and how the PLC know to send information to the HMI, information related to pressurization unit status. Taking the front lead away, what you will see on the top, you will find the water tank, and you have a floating valve. You see something floating on a blue water. That's the main intake floating valve. When the tank it is full of water, that floating valve will be restricted, so the water will not go in. But when the pump will start consuming the water, then that ball goes down, allowing the water, the main water, to fill the tank again. Also, you'll have a high and low water level probes that will send the information to the pressurization unit printed circuit board, and that information can be transferred into the programmable logic controller, which will send the information to the HMI. As I said, they are level of integration. Then you have the two pumps, as you'll see down the round circle. You have an arrow, which is one-way valve, and then a little bit on the top you'll have the pressure probe, the pressure transducer, which will tell the pressurization unit about the pressure into the system. Now you've seen what is inside: the pumps, the one-way valve, and the pressure transducer, and also the high and low level switches onto this water tank. Now on the top you will see a printed circuit board, and that printed circuit board will control the pumps, will collect data from the pressure transducer, and also from the high and low level switches. So that information will go into this programmable logic controller, and it will be sent straight to the HMI so you can see what's wrong. But don't get me wrong, it's very expensive to do a very complex integration. So what would people do? They will connect in series all these faults from this pressurization unit, and you will have just a common alarm. As far as I'm concerned here, you will see more wires that goes into this PLC. So you will have the pump status, pump 1, pump 2, you have the low level status, high level status, and the pressure status. This is a beautiful integration. All this wire will tell to the PLC what's wrong with the pressurization unit, and that will be displayed onto the HMI. And if you remotely control a store, like you'll be in another town and you don't want to send the wrong technician, if the boiler will stop because the pump stop, because the pressurization unit stop, you might can see a pump is broken and you can send an electrician to change the pump, not a gas engineer to spend 100,000 pounds, hundreds and hundreds pounds on the diesel or whatever for no reason. So just think about this. The level of integration, it is decided by the customer and the designer, because everything goes back to money. As far as I'm concerned, the only interest I have today is to show you how the system works. So you've seen that the programmable logic control collect data from the PLC and return the data accordingly to the system health. Well, as I told you, the motors, as you'll see, the green and the red wire goes straight to this printed circuit board, and also the high and low level switch and the pressure transducer goes again onto the printed circuit board. And all that information, it is controlled by this printed circuit board, which has got pre-soft, which probably only the manufacturer might change it, because people keep secrets their software. And finally, you'll have these inputs from the PLC, which goes in some relays, and the inputs, the digital inputs, will be returned into the PLC, telling to this PLC the pressurization unit status, and the PLC will send the data to this HMI, and the data will be converted on visual graphics, so you will know what the fault it is. Also, the pressurization unit have its own screen, which tells you what faults are. So if you have a communal arm, sometimes you can have only 2 wires or 1 wire, and then you say, okay, the pressurization unit have an alarm. Then you wouldn't know, because this is a very cheap integration, but you will know the pressurization unit stop the heating system, and then you will send the technician to see what's wrong with the pressurization unit. But if you have a very tough integration, then a very good integration, then yes, you'll be able to say even if a motor is broken. It is up to how much money the client want to spend. I work for big companies like ABM. I work a little bit for CTFM. I was a little bit unhappy with CTFM. I got pretty angry sometime because some issues which I don't really want to discuss. I consider myself a very thorough engineer, and I think the customer have the right to get the best from me, and I'm not going to lie and just to do a mumbo jumbo maintenance just because I want to satisfy my supervisor, alleged supervisor, or my manager, alleged manager. So yeah, but what I want to say, working for these big companies, I realized that like Marks and Spencer store, Sainsbury, they have their equipment remotely monitored, and sometimes these people which monitoring their equipment are in Scotland. And with many occasions, we had a big argument on the phone, me and the guy which were controlling and monitoring the system remotely. And we had a conflict until I realized that even if I was a maintenance engineer, there was not enough to set up my mind as a maintenance engineer. So I became analysis engineer, because with multiple occasions I found out that the integration was incorrect. Like one day at Marble Arch, I found out that the inputs had been mixed up. So if I would have a water leak from the pressurization, the HMI will tell me I have a gas leak, and if I have a gas leak, it will tell me I have a flood or something. So this programmable logic control will only tell you the story, but the story is written by a technician. So we can never blame a programmable logic control or a human machine interface. And the guy which is remotely monitoring, as an example, in Glasgow, something that happened in Exeter, cannot be 100% on his diagnostics unless the system was properly commissioned and checked and verified. Because if someone will mix the inputs, what you will see on the screen, it will be what the input will see, the input actually. So if you allocate the input to something else than to the original function that it was designed for, then the guy from Glasgow will have an incorrect information. Now I'll give you as an example the relay, which tells you that the pump is not working. If you reverse pump number 1 and pump number 2, these inputs, obviously he will tell you that the pump number 2 is faulty, and when you'll go there you'll see the pump that is faulty is pump number 1 because that's his label. You'll start to argue, but as long as the pump are the same is no problem. But if you have about 4,000 or 5,000 pounds difference in between these two pumps and you're not going to do an investigation, then yeah, you'll have a big tango. Thank you very much for watching my video, and I'm looking ahead to see you for other videos. Thank you. Bye.